We're going to take a look at an ozone generator. And this is one of the big commercial units. And here's a general disclaimer about these commercial units. They put out so much more than the little small ones that you would use in a bathroom that people and pets should not be in the same space that these things are in. And after the area has been treated and all of your smells have gone away, it should be thoroughly ventilated before you let people back in it, or pets. Okay, moving right along. I bought this locally off of one of the for sale pages, really cheap. And I kind of figured it had some issues, and they're not that complicated inside, and I fixed these things before. So I thought maybe I could fix this one as well and use it myself. And this is an older one, probably as much as 20 years old, and you can see it has its battle scars. These guys need to be refreshed ever so often. I mean, if you use it in heavy-duty commercial use, maybe once a year you'll have to change the plates in it. And maybe as often as every few weeks, you might have to take the top off and blow it out, and maybe even take the plates out and wash them. We'll get to that in a bit. So here's what the front looks like. Pretty simple thing. It's a big steel box. Rainbow Air Activator 1000. Da-da-da-da. Here's the power switch. You have a choice of having it on continuously, which is not a good idea, or putting it over here on timer, where this knob down here comes into effect, and you can set it all the way up to 24 hours where it will shut off. You got to have some serious stuff going on to run it up here. And this is an intensity control. It just varies the high voltage output. And that's pretty much it. And this is actually a little bit fancier one because it has a timer and it has an intensity control. And on the back, there's not a lot to see either. It's got a regular IDAC type cable input and two fuses. I'm not sure what these actually do. I think the little one here is the high voltage transformer by itself, and this is everything else, I think. So let's take a look inside. I have gone ahead and removed the screws. See, it's just your standard industrial clamshell sort of case, and it has some instructions here that basically says every 3 months or more, often if needed, and it tells you, clean it, do this, that, and the other thing to clean it out. And if the generator plates quit working, you have to replace them, blah blah. So this is the business right here. These are the generator plates you see the edge of, and they're behind this plexiglass wind tunnel. It's a nice Rotron fan over here, a really high quality industrial level one. And tip it up this way. And all of the actual electrical stuff over here is over here on the side by itself. So let me zip this cover off, and we'll talk about the plates first before I get into the electrical side. I suspected really that this one had some kind of issue, otherwise the guy wouldn't be selling it ridiculously cheap. But I took a chance on it because most of the time this electrical stuff, you really don't have any trouble out of it. He mentioned something about leads on the transformer, having to twist them, or they were corroded or something other. I'm not sure exactly what it was, what he said. And so this is just a plexiglass, and most assuredly it is plexiglass, really brittle. In fact, I took some of that thick, clear, here's right here, Gorilla Clear, duct tape. It's not as much thicker than packing tape, and it's designed to last a long time. And I just taped over these cracks, just went around both sides, so that's okay. And there's a foam strip right here that pushes down on the plates. And these plates are just sitting on here in a rack. And they're very simple. This is a sheet of ceramic, and this is a stainless steel screen on either side. There's no connection between them. It's essentially a capacitor is what you got going here. And these guys are cemented on, and it looks like some kind of high temperature cement, like you would cement in a thermistor or a thermocouple into a metal sheath or into whatever you're trying to measure. And there are 4 of these guys in here. And this is the replaceable element. Every so often you have to replace these. You know, see that staining? A couple of these I actually washed to see if I could recover them, but I couldn't. So what's happened to these is every stinking one of them has got a burn through hole in them somewhere where it's actually eaten through. When it does that, it's dead. It's not putting out any ozone to speak of anymore. And you can see the dark spots. I'm trying to find the one that has a really good looking burn spot on it. Well, not that a good looking burn spot. Yeah, I see that burn spot right there. Let me dance it around in the light. Right there, that's actually punched all the way through to the other side. And you can see how the alignment of those things are. So that burn spot has actually punched through to this side. These have nice frames that I think are soldered around them. I think that's what that is. But I don't know why they just don't leave the edge of the wire sticking out there. It's, I guess maybe a corona discharge. But you know, corona is how this thing works. And the newer ones don't have that. I was really stressed when I looked at what the original manufacturer ones of these things cost. These are 4.5 by 6.5. And they were quite pricey. I'd had to spend $100 to get this thing back up and running. And this model's been superseded probably quite a while ago, so that the version 2 of this thing, they shrunk these plates slightly, and I think the reason they did, I think they're 4 by 6, and I think the reason they did, maybe they physically wanted to reduce the size of the cabinet, but I think one of the reasons they did is because a long time ago the whole industry standardized on this size plate, and that means that you can buy these, and I found some from the people that make the universal plates for about $12 a piece in my hand. So hey, win. So that means that if you have a newer model of this, you got to go buy the plates from the manufacturer, and they're like $20 a piece. Like, I hate it when people do that. There was a couple of things I had to fix in this guy. There's a high voltage leads come off the transformer. One of them goes here, and the other one, and I know it's black, so yeah, there it is, goes up and around the back of the transformer. And from the factory, it had spade lugs on there, and they were stuck on these connectors. Well, they had corrosion had gotten to them, and I think that's why these plates went bad. And these things show signs of moisture, and dust will make them arc over, and dampness definitely will mess them up. So you got to keep these things away from moisture, and you have to keep them clean inside. So that's why they say every few weeks open them up. Oh, and I don't think I pointed it out. This thing has a place, you snap this top cover off, and it has a place for a filter in front of this fan, and this one did not have a filter in it. Another problem it had was, you see these, let me get the light just right, you see these stands. This is made out of some sort of fiber block stuff. One place in particular I used to work used this, and we got it in big sheets and cubes and whatnot and cut things out of it. And there's another bar right here that has squares cut out of it for these rectangles with a slot to stick down in. And on this corner one, the glue had let go and it was floating, and somebody had shimmed it back here with a piece of metal foil around all this high voltage. This thing runs at about 5,000 volts AC. So I fixed that. Everything was good to go there then, and I put these plates in one at a time and checked them, and they arced internally through this way. So I washed a couple of them, checked them again, dried them out with my heat gun, and no dice. So I said, oh well, I replace them. So this guy goes down in here and makes contact with the fingers on these two bus bars, and that puts 5,000 some volts AC across it. So that current can't really go anywhere, and the voltage is not enough to arc over. So it makes a corona discharge field all around this and breaks the O2 up and creates some O and O3, and those are powerful oxidizer, and then the fan blows it out in the room. And because you have so many of these, so much surface area in this thing, it makes a lot of ozone. Now, what about a lot? I don't know exactly. It's so many milliliters an hour. And, you know, you can look that up. You just look up the 1000 version of this, and it actually has a spec in there. They're very effective. You've done a thorough cleaning on a house. You've got the rug. You've cleaned the rug. You've got as much the smell out as you can. You know, sources of smell. Cigarette smoke, cooking odors, mold odors, mildew odors, and all of that. It doesn't do a whole lot of killing that sort of thing unless it's on the surfaces. It will actually disinfect the surfaces, and it will go in and disinfect anywhere the air can get. It won't remove stains or nothing like that. It can't do that. And then once you've got the physical cleaning done, then you can use this to get that last bit of smell out of the place, because the ozone is just like bleach, and it will go in everywhere and oxidize all those smell molecules out, and it will also kill it on contact things on surfaces. So when my parts come in, I'm going to slip those guys in here and check this thing out, and I'll have 100% working one, and then I can put it in the room downstairs we're having the issue in. Car smell, have a relative that wants to use it, and so on and so on. Heck, I might even rent the thing out. Who knows? And I'm going to do a little demo of what the arcing over actually looks like. So now I'm going to slip one of these guys in and do a little arcing over demo. It's hard to keep the camera oriented and find the little slots. And then the fingers barely do anything, and you should have them tweaked so they barely do anything until you get to that stainless mesh, and then to push a little bit. Can't be rough with these things. They are brittle. You can't be rough with this whole thing, because these things are fiber, and the glue will break loose, especially when it gets some age on it. So this is not something you go tossing around in the truck. And the reason I'm only using one plate at a time is because if you have all the plates in there, as soon as you turn the high voltage over, it's going to jump at the worst spot, and you'll never see the others arcing over, and you know, they might jump back and forth between them. So let me briefly, okay, there it is. Now this one's going to arc, I think, right down there. So I'm just going to punch it a couple of times. See, that plate's toast. Are we worried about grabbing this? It's AC. There's no capacitors in the high voltage circuit on these things. Not going to hurt anything if you touch it. Okay. See, that one's screwed up. It's arcing over there. And now that one is almost working, but I hear a little bit. No. See it right there? And let's try this last one. Oh yeah. I thought maybe I could turn them around and put put these fingers in a different location, and it might make a difference, but no. Once they're ruined, they're ruined. It's time to toss them and put some more in, I'm afraid. Let's go over the components and where they're located. oh yeah, you could see I got in my new plates and have them in place, and it's working great. Let's start with the input. Down here, way out of sight, and it's the deal on the bottom right there, is the standard power cord input, and right above it is the two circuit breakers. This one's a 1/2 amp and this one's 1 amp. And this guy right here is the safety switch that won't let it come on unless you have the cover screwed on, or you, as you saw me pushing it when I needed to test the plates. This wire's going right under and over here or putting power to the fan. And this long guy here is the high voltage transformer. These are pretty nice because they have the primary winding, the 120 volt AC winding, separate, that's it here, from the big high voltage winding that's completely potted in epoxy and sealed up. And that winding is connected to the plate connectors, these rails on either side with the fingers, by this wire here and another one that comes out of this side. You can't really see that well in the little blue connectors. So the big square block down here in the bottom with the terminals on it is that 24-hour timer, and the brown leads off of it go to a pot, the bottom pot on the front panel, and that adjusts the time. I don't know what the value of that pot is. It's quite rusty on the back, and I can't make out the numbers. And the big pot up here, a rheostat really, is a 1K ohm guy that's in series with the transformer primary, and that varies the power. Well, it's kind of crude and all, but it does well enough for this because there's only a few milliamps going through it. And on the very top is the power selector switch, or the mode selector switch, I guess you would call it. It's a center off, single pole, double throw. It either turns the thing on or it puts the timer in series, and that times it out. So it's pretty simple, pretty straightforward, and I've reverse engineered the schematic, so let's take a look at that. So I reverse engineered this thing, which isn't that big of a chore, since, as you can see, it's fairly simple. So let's go over the parts and let me run you through what everything does. So over on the left side up here, we have the line input connector, and it's your standard IEC type connector like you find on computers and other power supplies and whatnot. And immediately the power comes in and goes through the cover switch, the safety switch, you know, kind of the anti-dummy switch, so you don't stick your finger in it and get very nastily zapped off of it. And if you're working on it, as you saw me do, you have to put your finger on that switch and push it down to check anything, make any observations, make any measurements. And that's probably a good thing, because if it does zap you, your finger's definitely going to jump off of that thing. And then the power goes through the main circuit breaker, this 1 amp circuit breaker that's on the back panel, to the center of our selector switch. And it has off, manual, and timer positions. It's an off-center type switch. And when you have it in the manual position, it powers up this bus here that goes to the fan and through the circuit breaker, the 1/2 amp circuit breaker, the smaller one that protects just the transformer, to the output control, that big 10-watt rheostat, to the transformer windings, and then the power goes on to the grid. Now don't pay attention in this mode to this bus being connected to the timer module, because this is an output. And when the timer is sitting there off, like it would be if the switch was over here in the manual mode, this output is switched off. It has a little relay inside of here, so nothing flows either way out of this. Okay, now let's say we don't want to use it in manual mode, which most of the time you don't want to use it in manual mode, and
we want to use it on the timer mode. So starting out with it in the off position, you'd set up how long you want it to run on the timer knob, and then set up how much output you want on the rheostat, and punch the timer on, punch the switch over into the timer mode, and then leave the area. So then the power will flow down here into the line input on the timing module, and the time is controlled by this pot, as I mentioned, being connected to the two pot input connectors here, the one for the wiper and the one for the end of the pot. And then the power will go back out the out connector. And that will power up this bus, just like if you flip the manual switch and run the fan through here and run the high voltage transformer. So when this times out, and it's simply a resistor capacitor network. This is the variable resistor, and there's a capacitor inside of here, an RC timer. When this times out, relay drops out, and the voltage stops coming out the output. Pretty straightforward. Now the other thing we have over here is on the neutral side. You have this bus that goes down here and picks up the neutral side of the fan, the neutral side of the transformer, and gives the timer module a neutral reference to ground. Now, as I mentioned, this small circuit breaker, the half amp one, is basically in there to protect your high voltage transformer. So if you get a hard short across here, and not just the arcing over that I showed, it will trip this circuit breaker and protect your transformer. So that's the first thing, if this circuit breaker is tripping, you should look for is a hard short between these two bus bars. Far as I can tell, just a plate arcing through won't draw enough current to trip this. And if this circuit breaker is popping, it pretty much means that you have an arc fault over somewhere in the wiring insulation or inside of a switch, or the fan has gone bad electrically, or maybe, kind of as a long shot, the time delay module has gone bad internally and is causing it to pull a great deal of a great deal of power between the line and neutral. But now that would only happen if you switched it in the timer mode and immediately tripped the circuit breaker. But if you switched it in the manual mode, it ran perfectly normally. That would help you nail it down to the timer module. Now, most of the parts in this thing are available over the counter in industrial supply places and your normal electronic places like Newark and whatnot, and eBay and so on. This is a standard small micro switch. The circuit breakers are standard parts, both of them. The time delay module is an off-the-shelf industrial timer module. Both this pot and this rheostat are off-the-shelf items too, but it's highly unlikely either one of these will ever fail. They don't have really any significant stress on them. The plates, of course, as I covered, are readily available from a couple of suppliers. The only thing that might be difficult to find is this high voltage transformer. I don't know if the original manufacturer still sells them, and if they do, they're going to be really expensive. But I have noticed on eBay there are Chinese suppliers that are selling high voltage transformers for ozone generators really cheap in several different sizes, and they're part of kits sometimes to do it yourself your own ozone generator. Now, I'm not exactly sure why that's a thing, but apparently it's a thing. So you can pick these transformers up for maybe 20-30 bucks, which is not bad. But hopefully this is one of the least likely parts to go bad. Okay, that pretty much covers everything. I hope you guys get something out of this. So, even if you don't have this specific model, you can understand pretty much how they all work and fix the one you have. So let me close by quoting the prophet of the DIY guys, Red Green. If the women don't find you handsome, at least let them find you handy. See you next time.